Hi, we're continuing with my notes on life science and cell biology in a nutshell. Currently, we're learning about lysosomes. So, lysosomes contain acid hydrolases, which are targeted to lysosomes by the mannose-6 phosphate residues, which are recognized by these mannose-6 phosphate receptors in the trans Golgi network. So the outside folds of the Golgi apparatus, which we learned about previously. So packaging occurs from the Golgi via clathrin-coated vesicles. So which contain these hydrolases. So these enzyme proteins come out of the Golgi via these vesicles, and these receptors are used for recognition. So the trend of which take the acid hydrolases are taken to the lysosome, where they're used for breaking down of various macromolecules for like recycling. So molecules such as sugars, lipids, proteins, whatnot, whatever needs to be broken down are taken into the lysosomes via vesicles, and these acid hydrolases which are produced. These are proteins. Proteins. One of the proteins which are produced by the ribosomes in the rough endoplasmic reticulum, then shipped from via the Golgi folds. So the vesicles bud from the Golgi. The Golgi are in charge of processing and transport of various molecules. So these take these hydrolases to the lysosome, and the lysosome they're used for their own purpose of breaking down molecules. So the Golgi moves all kinds of proteins and lipids to wherever they need to go, whether inside or outside the cell. That's what the Golgi apparatus is for. So, and the endoplasmic reticulum is for production of proteins and lipids. So, just the synthesis of them. On the Golgi, they are modified and labeled for their specific destinations to various organelles inside the cell or to the cell membrane for export to the outside environment of the cell. So, transport vesicles fuse with a part of the cytoskeleton called endosomes, and the acidic internal pH of lysosomes causes hydrolases to dissociate from the receptor that brought them in, the mannose-6 phosphate receptor. The hydrolases, which are only in lysosomes because they work only at very low pH of 5, and the rest of the cell has pH of 7. So hydrolases only work within lysosomes, used to break down molecules. Hydrolases released into the lumen of the endosome. So the fiber protein structure which comes from the membrane, the endosome. So the receptors remain in the membrane and are recycled eventually back to the Golgi. Late endosomes mature into lysosomes as they acquire a full complement of acid hydrolases, which digests molecules originally taken up by endocytosis, or which come in from vesicles from different parts of the cell that need to be broken down. Parts of organelles, etc., molecules that do not function or not no longer needed that need to be broken down. So removal of Clathrin coat, these transport vesicles fuse with late endosomes. So transport vesicles coming from the Golgi apparatus. So phagocytosis, specialized cells such as macrophages take up and degrade. So these are specific type of cells which are specialized in degrading large particles, including bacteria, cell debris, H cells needing to be eliminated from the body. So endocytosis is similar to phagocytosis. So large particles are taken up in phagocytic vacuoles or phagosomes, which fuse with the lysosomes, resulting in digestion of their contents. The lysosomes formed in this way, phagolysosomes, can be quite large and heterogeneous since their size and shape is determined by the content of the material being digested. So here's shown. So you have the plasma membrane or lipid bilayer, hydrolytic enzyme mixtures on the inside with low pH. So glycosylated membrane transport proteins help with the bringing in of molecules. The first step, so autophagy appears to be enclosure of an organelle, like a mitochondria organelle, in a membrane derived from the endoplasmic reticulum. The resulting vesicle, an autophagosome, fuses with a lysosome. Its contents are then digested. So this is one example. Autophagy is responsible for gradual turnover of cytoplasmic organelles. So phagocytosis, you may have a bacterium taken in via vesicle. So this is a phagosome, a cell specialized in breaking down. So this vesicle from the membrane, but which may be referred to as endosome. So it combines with the lysosome, and it's low pH content with a lot of acidic content. So the hydrolases inside the lysosome break down. As also, you may have organelles. The same thing may happen with them. So membranes budding out from the endoplasmic reticulum combined with the organelle, and the vesicle joins the lysosome for breakdown as well. So then here you have lysosomes inside a mouse skin cell. Their lysosomes are the cell's recycling center. Here lysosomes in purple around toxic plaques and brain cell amyloid plaques. Failure of lysosomes to degrade substances that they normally break down results in accumulation of non-degraded materials An increase in the size and number of lysosomes within the cell eventually will result in cellular malfunction and pathological consequences to affected organs. So too much, because they are very acidic. So